We started off this morning, we went around the bend there, and we were sitting in those red rocks which belong to the spectacle suite. Okay, those are post-tectonic. Okay, what I forgot to mention, but probably can mention later on, are that there are younger rocks in the spectacle suite in the area. Okay, but we'll mention that later. So we went around the bend there, and we were still in the spectacle suite, but you basically saw charnokites at the last stop. Now we've moved closer, and you can actually see the town, the outskirts of the town in the distance. Okay, we're now sitting in this pink portion here, which belongs to the lekker drink. Nice. Lekker drink. Okay.
How do we spell that?
L-E-K-K-E-R. Like drink then. It means nice drink. Okay, this is a pink gneiss, which is what you find throughout the Mackerland. You either find grey gneisses or pink gneisses, and this is quite a typical example of a pink gneiss. Okay, if you look carefully, well, I don't have to look so carefully, there's a foliation in this. You see it? Look closer. It's very strong actually, very pervasive. It's basically going like that. East-west. You see that? Okay. Well, you need to get your eye in. Look closer instead of sitting on it because... Okay, so this is a typical quartzo-feldspathic gneiss. There's not much in the way of mafic minerals here. Okay, you can see it's basically feldspars and quartz. Okay, this is typical of the pink gneisses that you actually find throughout the Mackerland. Okay, so it's very extensive. You find it not only here but in the Kip terrain, further to the east around Aggeneys, all throughout the area. There has been a lot of debate as to the origin of the pink gneiss. What could have actually caused this? And there are three basic theories for what could have caused it. Okay, the first is it's a rhyolite, or it was a rhyolite before. Okay, the chemistry sometimes suggests that it's very high silica, as you imagine from quartz and feldspar. Okay, and it's quite homogeneous in its composition, typically, often. Okay, the only problem with rhyolites, if you remember from igneous petrology, is that they are very viscous magmas and explosive. Okay, so when they come out of a volcano, it's typically explosive eruptions. Okay, and you're not going to find them flowing for long distances far away from a volcano. The only problem with this as a rhyolite is that how come you find it over vast areas if it was actually a rhyolite? Second theory is that it was an arkose. Okay, an arkose, a sedimentary rock. Okay, it's sort of like an immature sediment with a lot of feldspar in it. Typically arkoses, however, are more sort of proximal to the source area in a stream. Okay, whereas further away downstream in the distal areas it becomes, you get rid of your feldspar and you start to become more quartz rich. So would you actually, and also the composition would be quite varied. What you find with these pink gneisses is that the composition is within a certain narrow range. Okay, and also there's no real evidence for the fact that it will be proximal to some sort of source area. So some people have kind of dismissed that idea. The third theory is it's actually a granite or some sort of intrusive rock. Okay. I don't remember what the problem with that theory was. The problem with that theory is that if you walk over it, you often find it interlayered with sedimentary rocks, quartzite lenses, or quartzite layers, gradational contacts. There's no sharp contact, so there's no real proof for an intrusive sharp contact with these gneisses. So what is the solution? Well, I think that in different areas you're actually having one of the three. Okay, so for example, in one area it could be arcosic in origin, somewhere else rhyolitic, somewhere else intrusive, rather than just being one of the three at one time.
It's a sac name.
Yeah, it's a sac name.
Anything weathering pink.
So anything that's pink, they've always just put it together as pink gneiss. I mean, people have tried to explain its origin, but typically I'd say, and like Paul Macy also agree, that it probably is different things in different locations. Okay. As you can see,
So, but does it occur differently in different locations?
no, it tends to look like this.
The same.
Tends to be like this throughout the mackerel, kind of pink coloured, you know, not much mafic minerals, quartzo feldspathic gneiss, pink weathering.
Dr. Bailey, did they do some isotope dating?
Well, they have, but you know, in different places. So what I think of, and Paul Macy agrees, or he said so, and I agree, is that you actually need to do a more comprehensive study. You know, sample, do geochronology, dating the rocks, doing the isotope, doing the geochemistry, comprehensively in different areas of the mackerel and see what you get. You're probably going to find it's different in different areas. Okay, but people just sort of study one area and then make a broad
assumption
about this is how it formed throughout the mackerel, but probably not. Okay, you can see that there's jointing here, quite prominent joints. Okay, what is their orientation? You can measure it. A lot of these joints again are related to the Pan-African. Okay, what you're finding with the Pan-African deformation is also a lot of retrograde epidote coming in this thing, epidote, and some potassium metasomatism associated with that deformation event as well, associated with the jointing. Epidote, you know, guys know what epidote looks like. It's light green. Okay, the foliation you've seen is the Namakwa foliation. It's this dominant east-west oriented. Okay, so these rocks, whatever they were, are pre-tectonic or syntectonic. Pre-to-syntectonic. Okay, and undoubtedly you're going to encounter this in your field area, so please take note. Can you guys see the foliation?
No.
There it is. That's also pink gneiss across there. Okay, the foliation is running more or less like this, east-west. Please get your eye in and see it, recognize it. It's a different orientation to most of the joints here. Not all of the joints, but most of the joints.
Guys, donne ton pinceau comme ça on prend les photos. Comme ça on prend une photo.